and got these extreme risks. If you want to see it largely through water, I think that's actually a helpful way. It's water that would, as well as temperature, it's water that would disrupt agriculture. You have to deal with droughts and floods. You're going to get more droughts in some places, more floods in other places. The whole pattern of rainfall and the seasonality of the rainfall could change on you. And then, of course, storms, hurricanes, and sea level rises. So a lot of this stuff comes through water. It's not just sort of it being a bit hotter and people suffering from heat stress and crops suffering from heat stress. That is there, of course, but it's they're much more varied and complex effects that result from this. So the first is the dimensionality of the effects and how they work. And the second thing to draw attention to is looking across now. You can see that these effects on those dimensions intensify as you would expect as temperature goes up. Now, what we now know from the science is that if we let things go on under business as usual, and I'll move to this in just a moment, we have to contemplate these very high temperatures. And 5 degrees is very high. 5 degrees, this is compared with temperatures just before the Industrial Revolution, say in the 19th century. 5 degrees centigrade is a huge change. We're now roughly 5 degrees centigrade higher than we were at the last ice age. Where you could live and what you could do and how you lived your lives, the whole physical geography and thus the whole human geography of the world was obviously very different when we were 5 degrees centigrade lower than we are now. It's surely pretty clear that the physical and thus human geography of the world would look very different if we were 5 degrees warmer than where we are now. You'd get sea level rises, desertification, agriculture radically changed, and so on. It would be a very different world. So those are the risks which we should be trying to avoid. We try to be as quantitative as we can about those risks, but the main argument, I think, however you try to quantify those risks, is that they're very large, that 5 degrees and above, which is probably more likely than not in the first part of the next century, if we go on as business as usual, is very risky. And that's really the crucial part of the argument. Now, let me go to the link between greenhouse gases and temperature. Now, these are the 5 to 95% confidence intervals. They're in red, you've got the ranges of where we could be if we managed to stabilize greenhouse gases in the atmosphere at 400 parts per million, 450, 550, and so on. So those are the outcome of policy if you manage to stabilize. What would that give you in terms of probabilities of different kinds of temperatures? And that red bar covers the range of possibilities from 5% at the bottom end to 5% at the top end, the 95th percentile. So that's what's possible, and the most likely outcomes are roughly in the middle of those red bars. The dotted lines going outwards refer to other models. You have to use physical models from the climate scientists to generate these probabilities. We've chosen a couple of fairly central models to give us the red lines. I put in the dotted lines on there because there are other models and they take you out into different territory. So we're not using a model here which is particularly way out. We're using models here that are pretty central in terms of climate science. So you can see from the graph here roughly the kinds of areas you might be in, although of course you don't know with certainty. With 450, if you stabilise there, you've got a roughly 50-50 chance of being above or below 2 degrees, but you're very likely to settle down below 3 degrees. At 550, you've got roughly 50-50 chance of being around 3 degrees and pretty likely to be under 4 degrees. And you can see as you move up the range here to these higher levels, then you get quite big probabilities of being up in these very dangerous ranges of 5 degrees and above. Now, where are we now and where are we headed? We're now about 430 parts per million, and we're adding about 2.5 parts per million a year, and that 2.5 is rising with